So, hi everyone, my name is Paola Pardo. I'm from Qbeast, and I'm going to show you a quick example of how easy it is to read-write with Qbeast format and what are the main benefits of this multidimensional index in the lake. So, first of all, this is how this is a notebook in an EMR cluster connected with Spark. And this is how easily you can download the Qbeast library. It's already on the Maven repository. So with only one line, you will have the library already set up in your cluster. So this is what we do first, and typical Java package error on the explain, just to make sure everything works perfect. So this is how easy you can write your data in the Qbeast format. If you're a Spark user, you will be used to this interface. So here, first of all, we're loading a data set that is writing in Delta. And for writing in Qbeast, the only two things you need to change. One of these is the format on the Spark API, which instead of Delta, Parquet, Iceberg, wherever, you will write in format Qbeast. And then you have to specify which columns that you want to index, because this is one of the main benefits of the Qbeast format. It allows you to index different columns at the same time. So this is the two different options that you have to specify when writing your data. Just to save some time on the demo, we will skip this part and we already load an already indexed data set that we have. And to read is the same, more or less the same semantic, just you don't have to specify the columns to index. You already did when you write. So here, when you read with format Qbeast, it will read the metadata and understand which are the columns that you indexed previously. So this is how you read. We will read the data or data set. And we're going to see the two main benefits from this format. One of these is what I said, the multidimensional indexing and filtering of data. So if you index with multiple columns and you want to retrieve the information in a range, in different ranges, you can benefit from this multidimensional index because it will just query the data that you need. You will not load extra data that it's not in this range of space. So we're going to compare a little bit how many files do you actually going to read, what is the IO improvement, what is the time improvement in this part. So for multidimensional filtering, here we're gonna see how Qbeast reads all the data. So this is a count with all the information. It lasts about 5-6 seconds, 5 seconds and forth, and you will see that the number of files. This is a screenshot of the Spark UI for this specific operation, which shows basically what is the amount of files reading, what is the amount of time that this operation will waste on your machines. So you can see the number of total files reading on this data set indexed with Qbeast, it's 89 files. The time of the operation is around 50 seconds, metadata time, and the size of the data set is 12.1 gigabyte. So what happens when we do a multidimensional filtering? Okay, it's more quicker, but the number of files read, it's 23. What that means is that we retrieve only the files that we need for this range query, for this multidimensional filtering. Also, the time for the operation, it has decreased, and also the size of files read. What happens if we try to do the same operation in the original data, which is not indexed with Qbeast? What we have is what, although it's more expensive, the operation, the number of files read it's increased reasonably. So we have 100 files, not just because it is partitioned by data, and this will create extra files. But we also see that the time for reading those files, so that the operation with the old format will read all the information and then filter the records in memory. So it will read this 12.4 gigabytes of data instead of these 3 gigabytes that you will really need. So this is one part. This is the part of multidimensional indexing. So you can do multidimensional filter pushdown, but also there's another benefit, which is the sampling. So each of these files will save a significant subset of data that you will not need to load all the data and then sampling. You just will need this specific percentage of data. So here we have a sampling with Qbeast, and we will see that we only read one single file. This one single file is the one containing this 1% of data that this query needs. We will do the same operation with the old format. We will see that for retrieving 1% of the data, you will have to read all the files of the data set. The time comparison of the two operations, it's pretty good, I think. And the size and everything, it's just 218 megabytes against 12.4 gigabytes. So this is a reasonable speed up. Also, for the curious ones, you can see how we can do this sampling pushdown, because here when Spark unfortunately doesn't support sampling pushdown for now. So what we do is we transform this sampling operation that you've seen in the first two steps of the plan, here and here, for a filter that Qbeast format will understand and process better. So it will stop looking when it has the files that correspond to that percentage. So again, we reduce the I/O of the operation and the data transfers between systems. So here we have seen a simple example of read, writing, and the benefits, but we will see what happens in a more complex or more larger query, how we can interact with the format in that direction. To save some time of the demo, I will just reproduce and go through the already executed, not executed cells. So what we have here is we initialize the two paths, one with the original data and other one with the Qbeast indexed data. We prepare the queries so we can create views to interact better with the SQL API. And we will compare the two different formats. No, we have a query with Delta here. It's a SQL query. It's a TPCDS query 82. And we can see that it lasts about 51 seconds. On the query with Qbeast, we have taken a sample of 10% and 1% of both the more largest tables, which are inventory and store sales. And what we've seen, it's exactly the same result. It's exactly the same numbers, but it lasts 5.4 seconds. So here we can really see the benefits in more larger, complex queries with sampling with Qbeast. So here's basically the whole notebook. We will probably share this piece of code with public paths to the dataset so everyone can test it out. And hope you enjoy it, and please feel free to start us on GitHub, leave us some comments, and let us know if we can help you with anything on your data lake. Thank you.